Hi my dear students, welcome back to the session. Today we need to discuss free body diagram for system of pulleys. Okay, till now we discussed free body diagram for the system of rollers and system of blocks. Now we need to discuss free body diagram for system of pulleys. How to draw free body diagram for this particular system by using our 5 statements. Okay, focus on the 5 statements. What are they? First statement, weight of the body always act vertically downward direction. Next, tension always pull the body. Third statement, normal reaction always act perpendicular to the surface. Fifth statement, at every point of contact on surface, two normal reactions will be acting, both are equal in magnitude and unlike in nature. Finally, fourth statement, inertia force and frictional resistance both always act opposite to the direction of motion of the body. Now, just apply those 5 statements to draw free body diagram for the 2 blocks. That's it. Again, here, write down free body diagram for the block 1, free body diagram for the block 2. Here it is what? Massless and frictioned pulley. Frictionless pulley. Massless and frictionless pulley. Here, tension always pull the block. Here, what is happening? It is moving in this direction. Tight side tension, slack side tension. Actually, it is moving in this particular direction. Tension always pull the body. Take it. This tension pulling this body. This tension pulling this body. Here, frictionless. Actually, strictly speaking, you will get tight side tension and slack side tension. T2 equivalents to e power mu theta. Here, mu is nothing but rolling friction, coefficient of rolling friction. Theta is the lap angle. But here, mu equal to 0, then T1 is equal to T2 is equal to T. Here both side tensions are same. Okay? TT. Here it is massless and frictionless pulley. Strictly speaking, what is the free body diagram for the pulley? Free body diagram for the pulley. Yeah. Draw free body diagram for the pulley. T1. This will be T2. Here it is. It is rotating in this particular direction. This is angular disturbance, angular motion. Inertia torque will be acting opposite to the direction of this particular rotation. I naught theta double dot or else I naught alpha. I naught alpha. This is the free body diagram. Here, this is R. Finally, what you will get it? It is rotating in this direction. So, this is the free body diagram for the pulley. Here, massless pulley. That is why no need to draw free body diagram. Okay. This part is very important for mechanical engineering students. We can discuss that part later. Now, we need to focus on free body diagram for block 1 and block 2. Focus on block 1. This is block 1, block 2. Focus on block 1 and block 2. What is the first statement? Weight always act vertically downward direction. Weight of the block always act vertically downward direction. Downward direction. Okay, so first statement was over. Next statement. Tension always pull the block. Of course, all tensions are same. Frictionless pulley, that is why all tensions are same. Same string, same tension. So, tension always pull the block. Tension always pull the block. Okay, here also, tension always pull the block. Okay, next. Normal reaction at contact surface. Here there is no contact surface. That is why no need to use third and fifth statements. Now fourth statement. Inertia force always act opposite to the direction of motion of the block. Here it is moving upward direction. So inertia force will be acting downward direction. M1A. Both are having same acceleration. Now here it is moving downward direction. Hence inertia force will be acting in upward direction. So total 5 statements are over. Now just apply equilibrium equations. Sigma V equals to 0, then T equals to F inertia 1 plus W1, M1A plus W1, W1A by G plus 1. This is tension T. Correct now? We can write M1 as a W1 by G, just to take W1 common. Now, here also applies equilibrium equations. Sigma V equals to 0, then sum of the upward force equal to sum of the downward forces. T plus inertia force 2 equals to W2. Here T plus W2 by G into acceleration W2. Here it is W2 by G into acceleration. So then T equals to W2 into 1 minus A by G. This is the another equation from free body diagram 2. Okay. So here equation number 1, equation number 2. Here how many unknowns? How many unknowns, tell me? We should build an expression for tension and acceleration. Tension equal to dash, acceleration equal to dash. How many free body diagrams? Free body diagram 1, free body diagram 2. 2 free body diagrams, 2 unknowns. Okay, so from every free body diagram you will get one equation. So okay, 2 free body diagrams, 2 equations, we can solve 2 unknowns. That is the format. Okay, we are having 2 equations in our hand. Now we need to solve these 2 equations to derive an expression for tension and acceleration. Right up here? Now we need to solve these 2 equations. Okay, it's a basic algebra. Okay, right on up here. Can I rub this? Now we got 2 equations. From the equations 1 and 2. Here T equals to this, T equals to. You can equate these 2 equations. That is W1 A by G plus 1 equals to W2 1 minus A by G. From here W1 plus W2 into A by G. Correct now? W1 plus W2 A by G equals to W2 minus W1. That's it. Finally, A equal to W2 minus W1 by W1 plus W2 into A into G will get it. This is the acceleration. Just substitute acceleration in any one of the 2 equations. Now tension T equals to 1 minus A by G into W2. Correct now? Equals to 1 minus A by G in the sense W2 minus W1 by W1 plus W2 into W2. Here what you will get, tell me? W1 plus W2 minus W2 plus W1 by W1 plus W2 W2. Finally 2W1 W2 by W1 plus W2. This is the tension in the string. Okay, it is very basic example for system of pulleys and blocks. Okay, so we have drawn free body diagram for the block 1 and block 2. We got two equations. Finally, we solve two equations to get the expressions for acceleration of the blocks. Acceleration of the block 1 and 2. Both are having same acceleration. Acceleration of the blocks equivalents to W2 minus W1 by W1 plus W2 into G. And then tension in the string is nothing but 2W1 W2 by W1 plus W2. This is all about one of the basic example in free body diagram for system of pulleys and blocks. Right up to here. Now we can solve some complicated problems regarding free body diagram for system of pulleys. Okay, so whatever the problem it is, you can happily draw free body diagram by using my 5 statements. Okay, right down up to here. Yeah, done. Let's have a look at the next problem. Yeah. A block is weighing W1 and it is resting on rough horizontal floor with coefficient of friction mu. Okay, a string attached to the block and it is passing over the pulley. Another end of the string attached to the block is weighing W2. Okay. Now determine tension in the string and acceleration of the block. Okay. Derive an expression for tension in the string and acceleration of the blocks. Okay. To build an expression for T and A. Okay. And here acceleration of two blocks must be same. Assume one direction. Of course, is acceleration A. So then the acceleration of the block 1 will be moving in this direction. Assume that it is a frictionless and massless pulley. Tension is same. Same string, same tension. Of course. Now start drawing free body diagram for the block 1 and block 2. Madam, free body diagram for the block 1. Block 1. This is block 1. Here, free body diagram for block 2. Pata, free body diagram for block 2. What is our statement? Weight always act. Vertically downward direction. Weight always act. Vertically downward direction. Next down. At every contact surface, two normal reactions reacting. Now I want to take R actually. N, R, R. Both are fine. R is acting in downward direction. Again, this is called reaction at the contact surface. And here it is what? Tension always pull the block. Tension always pull the block. Here, this tension always pull the block. Tension always pull the block. Normal reaction always act perpendicular to the surface. at every contact surface, two normal reactions in the acting both are equal in magnitude unlike in nature. Now, acceleration, this is the acceleration. Now, here, inertia force always act opposite to the direction of motion. F(I2) is equals to M2 into A. Here you can write weight always act vertically downward direction. Now here inertia force always act opposite to the direction of motion. M1A frictional resistance, okay na, equal to mu into R. Okay, mu into R. Here coefficient of friction is mu. Here frictional resistance equal to mu into R. Mu into N or mu into R, both are fine. That is up to you. Okay. So this is the free body diagram for the block 1 and block 2. All the statements are over or not? Check it out. Weight always at vertical down direction, paka. Normal reaction, paka. Tension, paka. Inertia force, and then frictional resistance. A resistance is negative. Now, from free body diagram for the block 1. Okay. From this, what we will get it now? We will apply equilibrium equations. Sigma V equals to 0. From here we will get R equals to W1. R equals to W1. Sigma H equals to 0. Here inertia force 1 plus frictional resistance 1. Sum of the left force equal to sum of the right forces. Correct now? Sum of the right force equal to the left force equal to right forces. Equivalence to tension T. M1A plus mu into R equals to T. R equal to W1. M1A plus W1 mu into W1 equals to tension T. Finally, what do we get? Tell me. Tension T equal to W1 by G into acceleration mu into W1. W1 into A by G plus mu. Correct now? T equal to W1 taken common, A by G plus mu. This is the tension. You got it from free body diagram for the block 2. For the block 2. What you will get? Tell me. Sigma V equals to 0. Here tension, weight acting downward, and inertia force. Only T plus inertia force 2 equals to W2. T plus M2A W2. Tension T equal to W2 taken common. 1 minus A by G. This is tension in the spring. Okay. Here you got tension equal to W1 into A by G plus mu. Here tension T equal to W2 into 1 minus A by G. Here we are having two equations. What are they? T equals to W1 into A by G plus mu. This is equation number 1. Here this is equation number 2. Solve these two equations to determine tension and acceleration. Okay. So that is the common sense. So finally we will get some set of equations. We are having set of unknowns. Finally we can calculate those two unknowns by solving those equations. That is the logic. Right up to here. This is block 1, block 2. Now, how to solve those two equations? How to solve these two equations? Tell me. From equation 1 and 2. Both are tensions now. You can equate it. A by G plus mu W2 1 minus A by G. Now, see here, what you will get here? W1 A by G, take this thing here, W2 A by G equals to W2 minus mu into W1. From here, what you will get here? A by G taken common, W1 plus W2 equals to W2 minus mu into W1. Then finally acceleration equal to W2 minus mu into W1 by W1 plus W2 into G. This is the acceleration. But please substitute this acceleration in any one of these two expressions. Directly will get it. Substitute in second expression. T equals to W2 into 1 minus A by G, W2 into 1 minus W2 minus mu into W1 by W1 plus W2 into G by G equals to how much you will get it? W2 now. Here W2 W1 plus W2 minus W2 plus mu into W1 by W1 plus W2. Finally, we will get W2 into W2 gets cancelled out. Here W1 taken common, 1 plus mu. W1 plus W2. This is the tension in the string. Okay, so this is all about. Okay, this is just one good problem actually. Finally, you got one beautiful expression for acceleration and tension. That's it. Right now, clear? Here it is W2. From here, W2 minus mu W1. This is the expression for acceleration of the blocks. This is the expression for tension in the string. Right up here. Next up. Now, next question. Next question. Okay, here it is. Inclined plane is making an angle theta. 1, 2. Okay. This is the system. Now we need to calculate tension and the acceleration expressions. Same problem. Just we made it inclined. That's it. Just to draw free body diagram for this particular block. Body diagram for the block 1. Okay, so here we have PD for the block 1. FBD for the block 1. and repeat it for the block 2. Block 2. What is the first statement? What is the first statement? Weight always act. Weight always act. Vertically downward direction. Next. Here also same thing. Weight always act vertically downward direction. Normal reaction na. So next is tension. Tension always pull the block. Okay na. Tension always pull the body. Tension always pull the body. Okay. Tension always pull the body. Yeah, that is up to you. You can assume one direction. So if it is moving, if it is moving upward direction, this is the acceleration actually. This is the acceleration of the block. Both are having same acceleration. Assume one direction. If you get positive value, our assumed direction is correct. If you get negative, we need to change the direction. Okay. Here you can't decide the direction by seeing the magnitude of weights. Because the direction of motion of the block will definitely be depending on theta also. Okay. Yeah. Direction of motion of the blocks depends on weight of the blocks, weight of the blocks, W1 and W2, angle of inclination, okay, that is why you can't decide the direction directly. Don't decide the direction by seeing the weights. Okay, so that is why I just assume one direction. I assume this particular direction. I will solve the problem. If you get a negative value in that case, our assumed direction is wrong. If you get positive value, our assumed direction is correct. Just draw free body diagram like this. Here it is normal reaction R. Normal reaction R. This is the inclined. So I incorporated a reaction at the contact surface. Tension always tension na. This is tension. Tension T. Tension same string, same tension. Weight always at vertically downward direction. Now incorporate inertia force equivalent to M1 into A. Frictional resistance equivalent to mu into R. Okay, now we are having only one reaction, that is I put R. Here tell me it is moving downward direction, it is assumed, then frictional inertia force M2 into A. If it is moving down, it should move up. Okay, I incorporated tension, reaction. This is Fr equivalents to mu into R. Okay, that is related to friction. I think I incorporate everything now. Here there is no frictional resistance. Here just apply equilibrium equations. First resolve the components. Theta, W1 cos theta, W1 sin theta, then sigma V equals to 0. In that case, what you will get it? Reaction R equal to W1 cos theta, sigma H equals to 0. Here tension, sum of the left force equals right forces, T equals to inertia force 1, W1 sin theta, frictional resistance 1, M1 into acceleration, W1 sin theta plus mu into R. What is R? Here you can write W1 by G into acceleration, W1 sin theta plus mu into W1 cos theta. Correct na? R is equal equal to W1 cos theta. From here what you will get it? W1 taken common. Here you will get A by G plus sin theta plus mu into cos theta. This is the tension T. Tension T. Next, here tell me sigma V equals to 0. Finally, you will get tension T plus inertia force 2. This is W2. T plus M2A equal to W2. Tension T equal to W2 minus acceleration W2 by G. W2 into 1 minus A by G. You got two equations. We are having two unknowns. You can have this on problem. Equation number 1. Equation number 2. Okay. Now, from equation 1 and 2, from the equations 1 and 2, from the equations 1 and 2, what you will get here? Just equate these two equations. W1 into E by G sin theta plus mu into cos theta equal to W2 1 minus A by G. Then what you will get, tell me? W1 plus W2 into A by G. You will get W2 minus W1 into sin theta plus mu cos theta. A equal to acceleration equal to W2 minus W1 sin theta plus mu cos theta by W1 plus W2 into G. This is the expression for acceleration of the two blocks. Acceleration of the two blocks. Just substitute this acceleration in that particular expression. Then what you will get, tell me? Tension T equal to W2 into 1 minus A by G. W2 into 1 minus A means 2 minus W1 sin theta plus mu cos theta by W1 plus W2. You can cancel G and G directly. So here W2 into W1 plus W2 minus W2 plus W1 sin theta plus mu cos theta by W1 plus W2. These two gets cancelled out. Finally, W1 into W2, you will get, these two gets cancelled out. 1 plus sin theta plus mu into cos theta. Correct now? By W1 plus W2. This is all about tension in the string. So this is the logic actually. So these are this is not a numerical problem, right? That is why you are getting this much lengthy expressions. Once they give numerical values, you will get very small equation. You can happily solve those two equations to calculate tension and acceleration. Right on up here. Next step. Right on up here. direction of motion of the blocks. This is another case. Direction of motion of the blocks. 1 and 2 depends on weight of the blocks, angle of inclination, theta 1 and theta 2. Okay, you can't decide the direction directly. Okay, so don't blindly follow the weights up. You will definitely get wrong answer. But for here, for time being, we need to assume one direction. We are both are having same acceleration. Okay, now draw free body diagram for the block 1. Free body diagram for the block 1. And free body diagram for the block 2. Now what is this? Yeah. And this. What is the first statement? Weight always act vertically downward direction. W1. Your weight always act vertically downward direction. Next up, tension always pull the block. Tension, 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 tension. Tension always pull the block. Yeah, this is the tension. Always pull the block. Okay. Here also tension pulling the block. Pulling the block. Next up, normal reaction. Normal reaction at the contact surface. Can I say it is R1? It is R1. Again, this is the actual way to draw free body diagram. It is contact surface. Okay. So here it is what? R2. R2. Normal reaction was over. Normal reaction was over. Third statement was over. Now incorporate fourth statement actually. This is the acceleration. So inertia force will be acting opposite to the direction of that. Frictional resistance will be into R1. Here mu, friction, coefficient of friction at all contact surface assumed to be mu. Okay. Next up, if it is moving up, it will be moving down. It will be moving down. So here we need to incorporate inertia force 2, M2A, frictional resistance 2, frictional resistance 2, mu R2. This is the way to draw free body diagram for two blocks. Okay. Here we incorporated reaction at contact surface, tension, inertia and frictional resistance and weights. Everything is pakka. Our 5 statements are over. Now just apply the equilibrium equation for free body diagram 1 and free body diagram 2. Here acceleration of the two blocks same. I told you now, here number of unknowns. Number of unknowns equal to number of free body diagrams. Okay, number of unknowns equal to free body diagram. Here, number of unknowns equal to number of free body diagrams. What are they? Number of unknowns, tell me. Tension and acceleration. Here, FBD, block 1, FBD, block 2. That is the logic. Okay? Number of unknowns equal to number of free body diagrams. From this particular free body diagram, you will get one equation. From here, you will get another equation. Okay? So, even though you are having sigma h equal to 0, sigma b equal to 0 here, once you combine it now, finally it will become one equation only. We have already seen it. Okay? So, this is the free body diagram and this is the procedure to derive an expression for tension in the string and acceleration of the blocks. Okay? So, if there is any numerical problem, you are in position to solve it. Okay? W cos theta, W1 cos theta, W1 sin theta. Here it will be theta 1, theta 1, theta 2, W2 cos theta 2, W2 sin theta. So, I think you are in position to get those equations, I guess. I can solve up to getting equations. After that, you are in position to solve those two equations to get an answer. Okay. From FBD for block 1, FBD for block 1, what you will get it? R1 equal to sigma. Here R1 equal to W1 cos theta and here sum of the right force equal to sum of the left forces. Here tension T equals to M1A plus mu into R1 plus W1 sin theta 1. Correct now? T equal to M1A plus mu R1 W1 sin theta 1. W1 by G acceleration mu into W1 cos theta sin theta 1. Finally, A by G plus mu cos theta 1 sin theta 1. This is all about tension. Equation number 1. So, from free body diagram for block 2. Diagram for block 2. What you will get, tell me? R2 equal to, what is R2? W2 cos theta 2. Next, here sum of the left force equal to sum of the right forces. Then what you will get it? Tension T plus M2A mu into R2 equals to W2 sin theta 2. Correct na? This force is equal to W2 sin theta 2. Finally, tension T equal to W2 sin theta 2 minus W2 by G into A, mu into W2, here R2 means W2, cos theta 2. Finally, W2 taken common, sin theta 2 minus A by G minus mu into cos theta 2. This is the tension T. Equation number 2. Equation number 1. You are having two equations. By equating these two, you will get an expression for acceleration. Substitute that acceleration in any one of the expression, you will get tension in the stream. That's it. So, if they give numericals now, solving these two equations will be very simple. Okay? Right on up to here. So, you need to take care of solving these two equations and getting the expression for acceleration and tension. Okay? Next term. So basic mathematics actually. Solving two equations. Okay? Next term. Now, see here. Block 1, block 2. Their acceleration of the two blocks are not same. Okay, so not remember, just observe. Observe the system. What is happening? It is a rough horizontal surface. Okay, same string, same tension, paka, and same string, same tension. After that, their accelerations are related. How they are related? See, the distance moved by block 1. Observe. Okay, observe each and every statement. The distance moved by the block 1 is S1. The distance moved by the block 1 in this particular direction. In this particular direction is S1. If it is moving towards right, this thing will come down. For example, 4 meters. The block moved in this direction 4 meters. Okay. The string, it is an extensible string. It is moving and passing over the 2 pulleys. Okay. Here, total distance moved by the block 1 is 4 meter. Then 2 meter will be settled here. 2 meter will be settled in the right side. Right now, it is okay. 4 meters moved by the block 1 towards right. It is moving towards right. Okay. Then 4 meter string will be passing over the pulley. Here, what is happening is 2 meter will be settled here, 2 meter will be settled here. The distance moved by block 2 will be 2 meter. Correct? 2 meter will be settled here, 2 meter will be settled here. The distance moved by the block 2 in downward direction will be 2 meter. That is the thing. The distance moved by the block 1 in towards right is is 4 meter. In that case, 2 meter will be settled here, 2 meter will be settled here. Then the distance moved by block 2 in downward direction will be 2 meter. Pata. Now apply same thing here. The distance moved by the block 1 towards right is S1. Then the distance moved by the block 2 in downward direction is S2 equivalents to S1 by 2. S1 by 2. S1 by 2 settled here, S1 by 2 is settled here. Now, velocity of the block is V1. Then, velocity of the block 2 is V2. V1 by 2. Correct? Acceleration of the block 1 is A1. Acceleration of the block A2 is A1 by 2. Now, acceleration A1 and A2 are related. Okay? Both blocks are not having same acceleration. Okay? Here, how many unknowns tell me? Tension T, acceleration A, and acceleration A2. Here, these two are related. A2 is equal to A1 by 2. Finally, number of independent values tell me either A1 and A. Total number of unknowns here 2 only. So calculate A1, you can happily calculate A2. Okay? These two are related. Wherever you see A2, replace with A1 by 2. Okay, na? Then what you will get? You will get two equations in terms of tension and acceleration. You can solve those two equations. Finally, you will get a beautiful expression for tension, acceleration A1, acceleration A2. The logic is we need to draw free body diagram for the block 1 and block 2 separately. Write down free body diagram for the block 1. Free body diagram for the block 1. Now, it's very simple. Yeah. What about this? Okay. Weight always at vertically downward direction. W1. Weight always at vertically downward direction. Tension. What about tension? Tension T. Tension. Okay. Tension always pull the block. Okay. Two tensions are acting here. So here this will be tension T. Two tensions are acting here. That is 2T. Two tensions are acting. Two tensions pulling the block. That is the point. Same strength, same tension. Okay. Now, at every contact surface, here it is reaction R. Reaction R. This will be contact surface. At every contact surface, two normal reactions will be acting. Tension chapter was over. Normal reaction, reaction chapter was over. Weight also over. Now, what about this is the direction A1. This is the direction A2. Now incorporate inertia force. Inertia chapter also over. F inertia. M1A. Here tell me. F inertia 2. M2A2. M1A1. Correct na? Frictional resistance. Here F R1 equivalents to mu R. Mu R. Frictional resistance at contact surface. There is no frictional resistance here. This is block 1, block 2. F R2 is equal to mu R. Mu R1. Okay. So only one reaction. No need to put R1, R2 like that. Okay. So first step. Start from weight. Weight chapter was over. Tension also over. Normal reaction over. inertia force over frictional resistance 1. There is no, the air resistance is negative. Tell me, free body diagram for the block 2. Here what you will get, tell me? R is equal to W1 and tension T equal to M1 A1 U into R W1 by G A1 U into W1 W1 into A1 by G plus mu. This is tension T. Okay, so you will get one equation here. What about this thing? Tell me. From here, 2T plus W2 by G into A2. 2T plus W2 by G into A2 is equal to W2. Tension T equal to W2 into 1 minus A2 by G. Prajñā by 2 unit. P equal to W2 taken common 1 minus A2 by G. Prajñā 2T equal to W2 into 1 minus A2 by G. That's it. Here it is tension T. Equation number 2. Once you solve these two equations, you will get tension and acceleration. Okay? Right on up to here. This point is very interesting actually. Yeah. The distance moved by the block 1 is S1, the distance moved by the block 2 is S1 by 2. The relationship between the accelerations A1 and A2. Draw free body diagram for two blocks. Apply equilibrium equations, you will get two equations. Solve those two equations, you will get one. That's it. Okay. Here from the equations 1 and 2. What will you get, tell me? W1 A1 by G plus mu equals to W2 by 2 1 minus A2 by G. Here A2 equal to A1 by 2. A2 is equal to A1 by 2. Just substitute this thing here. What will you tell me? W1 A1 by G plus W2 by 2 A2 by G. Here W1, what will you tell me? W1 A1 by G, W2 by 2 A2 by G, W2 by 2 minus mu into W1. Here A1 by G plus W2 by 2 G. A2 is equal to A1 by 2 W2 by 2 minus mu into W1. So what will you get, tell me? A1 taken common, A1 by G taken common, W1 plus W2 by 4. Here W2 minus 2 mu W1 Prajñā by 2. Here A1 by G 4 W1 plus W2 by by 4, W2 minus 2 mu W1 by 2. Finally, what you will get, tell me? Acceleration A1 equal to, we have 2 times W2 minus 2 mu W1, W2 minus 2 mu W1 by, here you can take G by 4 W1 plus W2. This is the expression for A1. We know that A1 is equal to A1, A2 equal to A1 by 2, then A2 is equal to G into W2 minus 2 mu into W1 by 4 W1 plus W2. These are the expressions for acceleration of the two blocks. Acceleration of the block 1, acceleration of the block 2. Once you substitute the acceleration of the block 2 in this particular expression, you will directly get tension in the spring. Understood now? Solving two equations, that's it. Just add this equation. Okay, now convert A2, write A2 in terms of A1. Then everything will come into 2 equations. You can solve the problem. That's it. Next. What about tension T? Tell me. Tension T equal to W2 by 2 1 minus A2 by G. W2 by 2 1 minus, what is A2? GG gets cancelled out. W2 minus 2 mu W1 by 4 W1 plus W2. Correct now? GG gets cancelled out. W2 minus 2 W1. Finally, W2 by 2, 4 W1 plus W2 minus W2 plus 2 mu W1 by 4 W1 plus W2 . Yeah, W2 gets cancelled out. Yeah, 4 W1, 2 mu W1, 4 W1 plus W2. Here what do we get, tell me? W1, W2, W1 taken common. 2, you can cancel 2 now. So we are 2 plus mu W1. W1 taken common, 2 2 ja, by 4 W1 plus W2. So finally tension T equal to W1 W2 2 plus mu W1 by 4 W1 plus W2. So finally you got an expression for tension T and acceleration of the block 1, acceleration of the block 2. That's it. Next, better? Just look on the next problem. theta 1 and theta 2. Okay, so block 1, block 2 and block 3. So same string, same tension. Okay, same string passing over the 3 pulleys. In this case, same string, same tension. Okay, here acceleration of the block 1 is A1, acceleration of the block 2 is A2, acceleration of the block 3 is A3. Acceleration of block 3 is A3. Okay, so it is very simple actually. If the distance moved by the block 1 is S1, okay, so just assume that it is moving down, then block 3 is moving down, block 1 and block 2 will move in this particular direction. Of course, this is assumed these two will move in this particular direction. Okay, so here it is very simple. The distance moved by the block 1 is S1. Then what is the distance moved by the block 3? It is nothing but S1 by 2. S1 by 2. The distance moved by the block 2 is S2. Then what is the distance moved by the block 3 is S2 by 2. If it is V1, V1 by 2. If it is V2, V2 by 2. If it is A1, here it is A1 by 2. A2, A2 by 2, and this will become A3. Okay, so acceleration of the block 3 equal to A1 by 2 plus A2 by 2. That is the thing. Okay, so these two blocks are moving very fastly. Okay, now this block will move downwards in the same fashion. Okay, so here A1 by 2 plus A2 by 2 it will be plus 2. Okay, now so just now we solved the problem up to here now, half of the thing. We combined both the things. Okay, so up to here you will get S1 by 2, A1 by 2. So combine up to here, you will get S2 by 2, E2 by 2 and A2 by 2. Combine both the figures and you will get A3 equal to this. Number of unknowns, tell me. Number of unknowns here. Tension T, acceleration A1, acceleration A2. Here A3 is depending on the A1 by A2. Okay. Number of unknowns here is 3. Number of free body diagrams you will get. Free body diagram for the block 1, block 2, block 3. Now just draw free body diagram for the block 1. Free body diagram for the block 1. Here free body diagram for block 2. Finally, free body diagram for block 3. Just to show how to draw free body diagram for this, it is very lengthy problem. This type of questions won't come in data. Just to see the procedure, how many unknowns, just to have a look on the number of unknowns, how to write the expression for acceleration A3. Some points are important. That is why we are discussing. Okay, now. So here, see this, and this is the thing. And the block 3. Step by step. What is the first statement? Weight always act vertically downward direction. Here also weight always act vertically downward direction. weight always act vertically downward direction. Next, tension always pull the block. Tension always pull the block. This particular tension always pull the block. Here 2T. 2T is pulling the block 3. Okay. Block 1, block 2, and the block 3. Next, normal reaction. Reaction here is R1. R1. Here reaction now. This particular thing is this. Reaction R2. Reaction R2. This is the thing. Okay. R1, R2, Pakka. Next up, inertia forces. So here it is what? A1. This particular thing is A2, A3, A1 plus A2 by 2. Just have drawn the directions of motion of the blocks. This is assumed direction. Okay. Now, inertia force will be acting opposite to the direction of motion. Inertia force M1 A1, frictional resistance mu R1, then inertia force M2 A2, frictional resistance mu R2. Okay. Here also same thing now. I3, M3, A3. That's it. Okay. Now here this particular thing will be theta 1, W1 cos theta 1, W1 sin theta 1, here W2, W2 cos theta 2, W2 sin theta 2. This is all about free body diagram for the block 1, block 2, block 3. Here I told you now, number of unknowns. Number of unknowns equal to number of free body diagrams. Here. Okay. From one free body diagram, you will get one final equations. Here we are having two only. Sigma h equal to 0, sigma b equal to 0. But you will combine both. Finally, you will get one unique equation. Here FR1, UR1. This will be FR2, UR2. Don't feel that unnecessarily you are drawing free body diagram. This is the actual way to draw free body diagram for the blocks. Even it is unnecessary, that doesn't matter. Follow the methodology. Okay? Don't blindly draw free body diagram. Okay? So here, number of unknowns. What are they? Tension T, A1 and A2. Here APD 1, 2 and 3. FBD for block 1, block 2, block 3. 3 block free body diagrams and 3 unknowns. You can happily solve the problem. Okay. This type of questions won't come in gate, but procedure and methodology is important. You are in position to draw free body diagram. They may ask free body diagram only in exam. Okay. So how to draw free body diagram? They gave this much big figure. Nothing wrong in that. They asked you to draw free body diagram for block 2. Block 2 only asked. They asked only acceleration A3. Anything is possible. So you are in position to know everything, at least methodology, how to draw free body diagram, and number of unknowns, number of free body diagrams, how many equations will get it, how to solve the problem. Just have a look on it. That is very important. Next, this is a wonderful question. Next, just I am changing it. Just I am changing a little. I am directly connecting the block. I am directly connecting the block 3. Don't drop the free body diagram. Yeah, yes, will be theta 1, theta 2. Okay, so block 1, 2, 3. Okay. Here it is very simple. Just I am assuming one direction. This is the thing. A3. If it is the case, it will move like this. A1. Will move like this. A2, yeah, same string, same tension. That means tension here and here will be same. Of course, T1, T2, both tensions are equal. T1, T1. But this tension is need not to be equal to this now. If we got these two pulleys, two different tensions, same string, same tension, but different strings, different tensions. T2, T2, here it is T2, that's it. Remaining things are same. Here one more thing, just to pull downward direction, the distance moved by all the blocks will be same. Right now, if I pull downward direction, the distance moved by block 3 is 5 meter downward direction. Same 5 meter will come like this, same 5 meter will come like this. Okay? That is why A1 equal to A2 is equal to A3 is equal to A. Right? All blocks are having same acceleration. Just feel it. Just you need to move this block downward direction, then these two blocks will come. Okay, now the distance moved by block 1, 2, 3, everything is same. Paka. Now, number of unknowns, tell me. T1, T2, acceleration. 3 unknowns. Okay. Here tell me T1, T2 and acceleration A. Okay. Just to change the diagram. For block 1, what you people are getting? What are the changes? T1 you will get it, T1 you will get it, and here acceleration A1, that's it. Acceleration A1 becomes K. Okay, A1 becomes A, that's it. Here, in this case, it will become T2. Acceleration is A. Acceleration is A. Acceleration is A. Here T1 plus T2. Acceleration is A. Here A3 is equal to A. A1 is equal to A. A2 is equal to A. Any changes? Pakka. Exactly same. Nothing changed here. Okay. So number of unknowns, number of free body diagrams equal to number of available equilibrium equations. Number of equations, not equilibrium equations, number of equations. In every free body diagram, you are having two equilibrium equations. Once you combine those two, you will get one unique equation. One unique equation here, one more unique equation here. Same. Total three unique equations equivalents to number of unknowns. Number of unique equations, number of unknowns, both are same. So you can happily solve those two, solve those three equations. Finally, you will get D1, D2, A. That is the view. Here good points are acceleration of all blocks same and tension in the first string equal to T1, tension in the second string equal to T2. Same string, same tension. Same string, same tension. Two different strings, two different strings, two different tensions. That's it. Again, this is the way to draw free body diagrams and getting unique equations and solving those equations, finally getting unknowns. This is all about free body diagram and applying kinetics of rigid bodies. Okay? So tomorrow you can solve some more problems regarding free body diagram. Okay? Till now we discussed free body diagram for system of rollers, free body diagram for system of blocks and friction related problems. Finally we incorporated free body diagram for system of pulleys and blocks. Okay, this is the theory part. Okay, so some solved examples and all. Tomorrow we can solve some previous year questions and some practice questions for GATE. Okay, this is all about free body diagram. It is a wonderful tool to solve the problems. Okay, you can solve most of the problems in design by using free body diagram. Okay, you are in position to apply equilibrium equations and drawing free body diagram. It's a great tool to the student. I am focusing on that. I think I may spend around 15 hours in this particular methodology. Get good experience in free body diagram, improve your knowledge, then you will definitely feel good while solving problems in total design. Thank you. For queries, drop a mail to Prajñā Institutions@gmail.com. Thank you. You can meet in the next class.